It's your friendly math tutor, Miss C here, and today we are talking all things radical operations, specifically adding radicals, subtracting them, multiplying them, and dividing them. And then we have a bonus practice where we are combining multiple operations together. Let's start with adding radicals. So the big idea is that radicals must be common in order to combine. So a way a question might ask you to do this is that it might say simplify each radical. So we have 5 root 2 plus 9 root 2. What I mean when I say common is you're going to notice that both of these terms have the radical root 2. That means we can combine these two radicals together. So we are looking at 5 and 9. Those are our coefficients, and that's what we add together. So 5 plus 9 is 14. Our radical is root 2. That's what makes these like terms, so it stays root 2. Think of this the same way that you think of a common denominator when you're adding or subtracting fractions. You add the numerators and you keep the common denominator. In radicals, you add the coefficients, you keep the common radical. All right, so that is the simplest case. If it wasn't 5 root 2 plus 9 root 2, if it was like 5 root 2 plus 9 root 3, you can't simplify. That's as simplified as it gets. But we might have something that looks like this. So at first glance, these don't look to be common, but what I notice is that I can simplify root 12 and I can simplify root 27. And what we need to figure out is when we simplify them, do we have something in common within the radical? So the way I like to do this is I like to look at what perfect square lives within 12? So I'm thinking of the factors of 12. I have 6 and 2. There's no perfect square there. I also have 4 and 3. 4 is a perfect square. And what I mean by that is when I take the square root of 4, I get 2 out. I get a whole number out. So I'm going to rewrite this as 5 times root 4. Oops, that was not root 4. But I'll change that to root 4 times root 3. It actually doesn't matter what order you write this in. Okay. And when I do that, I get 5 times the square root of 4 is 2 times root 3. So my simplified version is 10 root 3. Okay. We're going to do the exact same thing with the next term. So we have 9 times. All right. 27 is easy because there's only 2 factors other than 27 and 1. And that is 9 and 3. So I'm going to say that this is 9 times root 9 times root 3. And as a quick check, root 9 times root 3 is root 27. So that works. So let's go ahead and simplify this. We have 9 times, what's the square root of 9? It is 3 times root 3. So if we simplify this, we get 27 root 3. So now I'm looking here at my 2 terms, and I have 10 root 3 plus 27 root 3. I'm noticing that I have my radical is root 3 in both of these, which means these are like terms and I can combine them. All we're going to do is we are going to add the coefficients. So 10 plus 27 is 37, and we keep the radical. So as a simplified expression, we have 37 root 3. Okay, that is adding. Let's look at subtracting radicals, and no big surprise here. The big idea is still the same. We have to have a common radical, similar to subtracting fractions, very similar to how we add fractions. You have to have a common denominator. So it's pretty straightforward. We have root 5 in both of these terms. That means all we're going to do is we are going to combine the coefficients, and then we keep root 5. So I'm going to even just start by writing root 5 here. And we're just going to say 23 minus 12, and that is 11. So our simplified answer here is 11 root 5. And then, much like the last problem we did, we're going to practice subtracting this in the same way. So we have 6. The perfect square in 20 is root 4 times root 5. That gives me root 20. And then I'm going to work straight across here. For the perfect square in 4 is 9 and root 5. Okay, so I'm going to go ahead and simplify. I get 6 times 2 times root 5. By the way, if you need a little more practice on simplifying radicals, I have a video for that, so I'll link it below. All right, so this gives me 6 times 2 is 12 times root 5 minus 12 root 5. We can combine these and look what happens. 12 root 5 minus 12 root 5 is 0. So our simplified expression is 0. All right. Now, this is an example of something we can't combine. We can't combine 2 root 10 minus 11 root 7 because our radicals, we don't have anything in common. They're not like terms. This is as simplified as this expression can get. And in this one, if I go through the process of simplifying, and you do have to do this at times, right? I'm looking at this and I could continue simplifying, and you would want to do that. But I'm noticing that the parts that are not perfect squares are a root 2 and a root 3. Those are not combinable. So we can't combine. So this is as good as it's going to get. Actually, I'm going to simplify this for you so you can see what a simplified expression would look like. But it's going to end up with 2 terms instead of a single term. So we end up with 45 root 2 here plus 30 root 3. And this is as simplified as we can get. All right, so big idea. If your radicals, what's under the radical bar is not the same, you cannot combine in addition and subtraction only. All right, now let's look at dividing radicals. So very similar to when you have exponents in your dividing, right? You can just divide them out. So this is really equal to, if we wanted to, 100, the square root of 100 divided by 2. These are equivalent expressions. So however you want to do this, you could say this is 10 root 2 and then rationalize the denominator. Or you could say this is root 50. Okay, we're going to get the same answer regardless. So here I know that I have root 25 times root 2, okay? And that gives me 5 root 2. So for those of you who don't like rationalizing the denominator, or you don't even know what I mean, moving to this form can sometimes be faster than trying to rationalize the denominator if that's not your jam. All right, so on this one, we have coefficients. We have 18 divided by 3. Okay, so I'm going to go ahead and do that. That gives me 6. And then I'm going to just say that I have 72 divided by 6. And then I'm going to simplify from here. So I end up with 6. And 72 divided by 6 is 12. So I have 6 times the square root of 12. And there is a perfect square in 12. So I'm going to go ahead and write that out because I know that 12 has 4 as a factor. And 4 is the perfect square times root 3. So I know that this is going to be 6 times the square root of 4, which is 2, times root 3. So that gives me 12 root 3, and that is our simplified expression. Okay. Let's jump to multiplication. So again, we can multiply any type of radical, just like we can divide any type of radical. We are going to multiply the coefficients together first. So 6 times 3, 2 times 3 is 6. And then we multiply the radicals together. So root 5 times root 10 is root 50. And then we simplify. So this is 6 times the perfect square in root 50 is root 25 times root 2. So that becomes 6 times 5 times root 2. That gives me 30 root 2, and that is our simplified term. All right, and then this is going to come in handy when we get to some more complex math things. We can have binomials that include fractions that we have to FOIL or distribute. So the way we're going to do this, I'm going to walk you through this. We say 5 times 2 is 10. And this is where it gets a little tricky. We have 5 times negative 4 times root 7. So 5 and 4, negative 4 get multiplied. So that gives me negative 20 times root 7. Okay. Then we have 3 times 2, which is 6. That's positive times root 2. That gives me root 2. Then we have It's the most complex one. I'm going to make this negative because I have a positive times a negative. We have 3 root 2 times negative 4 root 7. So we multiply the coefficients. 3 times negative 4 is negative 12. And then root 2 times root 7 is root 14. Okay. Pretty gross here, and these are pretty yucky roots. Sometimes the roots will multiply out, and then you have a nice looking expression. This is not a nice looking expression, and this is as simplified as you can get because you have root 7, you have root 2, and you have root 14, and those can't be simplified any farther. So this is your simplified FOIL. All right, now we are shifting to simplify expressions where there are multiple operations present. So again, the directions are going to be the same. Simplify each radical. So here we go. We have root 27 plus root 54 all divided by root 3. So there's a couple ways that you can approach this. You could simplify the numerator first by simplifying each radical. Or you could do what I am going to do is I'm going to divide each of the terms in the numerator by root 3. So the wrong way to do this would be to only divide one of the radicals by root 3 in the numerator. Because root 3 is under both, you have to divide by both. Now, the reason I'm doing this is because I know that 27 is divisible by 3, as is 54. So I'm going to go ahead and start by writing this as the square root of 27 divided by 3. Remember, that's the division property, plus the square root of 54 divided by root 3. And then I'm going to simplify from there. So 27 divided by 3 is 9, plus 54 divided by 3 is 18. So now I have root 9 plus root 18. Root 9 is a perfect, or 9 is a perfect square. So when I take the square root of it, I get a whole number, which is 3. Root 18 has a perfect square in it, and that perfect square is 9. So I'm going to rewrite this as 9, square root of 9, times the square root of 2. So this becomes 3 plus 3 times the square root of 2. Now, I can't simplify this any further. This is as simple as it gets, but it is a lot better than what we started with up here because we have one radical and it's in a much more simplified form. All right, let's look at one more. This is a subtraction problem, and you're going to notice we only have one radical, but here's the catch. That 2 is divided once again into both terms. You might notice that I'm stressing that because this is one of the most common mistakes I see in math is students try to simplify and they forget to divide both terms in the numerator by the denominator. That will create an inequivalent value and it's wrong. So don't be that person. Okay, so I'm going to go ahead and start by dividing 6 by 2, which gives me 3 minus, and then I'm just going to write this as root 32 divided by 2. Okay, you could do this in another way, like you could have simplified root 32 first, but I decided not to do that for some reason, and I'm thinking maybe that would have been the better way, but that's okay. So root 32 has a perfect square in it, and that perfect square is root 16. Okay, I'm going to show you something about 32 in just a second, and that is root 16 times root 2, and that is all over 2. Okay, so I'm going to go ahead and simplify this. Root 16 is really 4 times root 2. That's still over 2, and now I can simplify this. 3 minus 4 divided by 2 is 2 times root 2. So like our last problem, this is as simple as it can get because 3 and root 2 are not like terms, so they cannot be combined. Okay, so that is our answer. Just really quick with root 32. If you didn't know that 16 was a factor, what you could say is, I know that I have root 4 times root 8, right? That's root 32. But within this root 8, I know that there is also another 4. So that's really like root 4 times root 2. So now you know you've got root 4 times root 4, which is root 16 times root 2. So that's how you can get to root 16 times root 2. It's just a little bit longer, or you could simplify as you go. Okay, that was a lot of information on radical operations. Thanks for taking the time to learn these with me. Make sure to subscribe for more math videos. Till next time, remember, you've got this.